Translating a function involves moving the original function up, down, left, or right. Here in this table, I have the transformation that you'll see, and then what you'll do as far as shifting with what you identify as A, B, C, or D. If the number is outside, the constant is outside and adding, you shift it up. If it's outside and subtracting, you shift it down. If the shift is inside of the function and it's addition plus C inside, you shift it to the left C units. And if it's subtraction within the function itself, you shift it to the right D units. So these here, these last two are usually counterintuitive. So you think minus, you'd be going to the left, and plus you'd be going to the right. But it's exactly the opposite when it's inside of the function itself. So looking at this first example, it says the graph of f of x equals x squared is showed below. Identify the shifts and create a new graph, which is g of x plus 2 squared. X plus 2 squared. So this plus 2, x plus 2, that's inside of the function. So inside the square, it's being squared. So that's just like this form right here, the x plus c. So we're shifting left 2 units. Shifting left 2 units. Okay, so taking these points that we already have, we're shifting them to the left 2 units. I'll start at the origin and shift it to the left by 2, put a dot right here. I'll then use these points here, so this 1, 1 is a point, shift it to the left 2, gives me negative 1, 1. Negative 1, 1 is shifted to the left by 2, that gives me negative 3, 1. Now I want to shift this one to the left by 2, and this is sometimes even a little easier to do on the graph, the original graph itself. So like just count to the left 2 there. Shifting it to the left by 2. If you want to draw it by itself, though, you can just take those same points and plot them there. So here, I drew the graph of g of x, which is x plus 2 squared. That's the graph of this one. Which I did in blue over here. I'm going to get rid of that one though. You can do multiple shifts, and these shifts, you have to identify each of them, and you have to make sure you do both of them. So this is, we're looking at v of x, which is, well, I guess you could call it a piecewise defined function. It is still continuous, but we're going to draw the graph of v of x minus 4 plus 2. There's two different translations here. This one that's inside of the function. Now that's inside of the function, it's minus 4. So that's a shift right by 4. This is on the outside, and it's plus 2, so it's a shift up by 2. Shift up by 2. Okay, so I'm going to do a similar thing that I did before. I'm going to take this graph here, and it's shifting right by 4. So from this point right here, I'll count 4. 1, 2, 3, 4. And then up to 1, 2 to this point right here. Take that point right there. I'm going to get rid of those then. Do the same thing for this point here. 1, 2, 3, 4, up 2. Point right there. Okay, this is the next point up here. To the right by 4. 1, 2, 3, 4. 1, 2, up. Do the same thing here. 1, 2, 3, 4, up by 2. And that should be good enough for us to create this graph. So I'm going to take this straight line here and make it blue. So between these points is this straight line. And we then have a line segment between these two. Oop, I did the wrong color. Line segment between these two. Another line segment between these two. And then an arrow up to the right here. Okay, so that's the translation of it. If I wanted to put this in its own graph, I could copy it over. I'm gonna just copy it this way using my iPad. I'm just gonna select it and copy and bring it over. That's good. Shift A right 4 and up 2.